These are the two virtual machines. The left one is the target machine and the right one is the host machine. The two machines are connected by serial port TTY-S1. So when I send a message from the terminal of the target machine, we can see that the host machine will also have the message in the terminal. We use the copy command to copy the original config file into the new kernels folder. So we can see that the config file is now in the new 4.4.101 kernels folder. Here, we enter the sudo make menu config command to open the kernel configuration window. And we make sure that the 64-bit kernel option is selected. And also the KGDB kernel debugger option is selected in the kernel hacking category. Here we make sure that these 5 commands in the configuration file have values equal to y. This is the execution of the sudo make command and the execution of sudo make modules install command, and then the execution of the sudo make install command. These are screenshots of the grub update process. I comment out these 2 lines. Add no KASLR. Then update the grub again. Then we add KGDB wait and KGDB OC in the grub configuration file. After the updating process, we now have a VM Linux file in the Linux 4.4.101 folder. And we can copy the VM Linux file from the target machine to the host machine using the scp command. Now when I reboot my target machine, I will choose these 2 options, and then I will eventually reach this black screen that says KGDB waiting for connection from remote GDB. Then in the host machine, I connect to my target machine and then type the continue command. You can see that after I enter the continue command, the target machine has started working again, and I can now log into my target machine. These are the 2 system call tables that I found online. In the host machine, I set the do_rmdir function as the breakpoint. So in the target machine, when I type the rmdir test folder command, you can see that as soon as I press enter, the machine has frozen. And in the host machine, I can type the print path name command to get the path name parameter of the do_rmdir function that caused the breakpoint. To create a breakpoint for the mkdir function, you can see that I chose the security path mkdir function as the breakpoint. Now in the target machine, when I type the mkdir test folder 2 command, you can see that as soon as I press enter, the machine will freeze. And now I can go to the host machine, and it will show that a breakpoint has been hit. The security path mkdir function that I chose for breakpoint has these 3 parameters. So when the breakpoint was hit, their values can be printed in the host machine. Now I can type the continue command, and then the target machine will start working again, and I can start typing things in it. After I updated my host machine and installed the perf tool, I can now type perf to get information of the most commonly used perf commands, or type perf trace help to get the details of the perf trace command. This is the mtTest program file and its perf trace results, and also the file copy test program file and its perf trace results. Then we compare the two trace results in Notepad++. We can see that the execution of file copy test has more system calls and requires more time than mtTest. Here I compare the execution time of 4 system calls in file copy test when copying files of different sizes. My results are very interesting because the execution time doesn't get longer as the file size gets larger, but we can see that the clone system call always takes the most time. Open takes the second most time, and the rest two takes about the same time. This is the result of the perf report command. For my extra perf command, I choose the perf top command. This command generates and displays a performance counter profile in real time, showing the percentage of CPU usage of each currently running function. We can use this information to find out which functions use up the most CPU time. To test this command, I wrote this CPP file that contains an infinite loop in its main function, compiled it, and ran it. Then, I opened another terminal while that program is still running, and I typed the perf top command. You can see that the main function of that program file has taken up almost all of the CPU time because it is running an infinite loop. But if I stop that program from running, and enter the perf top command again, you can see that the CPU usage has gone back to normal.